we are continuing on here in Fusion and with basically setting up some different types of cutting tools for our 123 block. So where we were using some of the Haas tools, now I'm in MSC's catalog. We're going to actually come in here with a different type of cutting tool, what we referred to as an inductible high feed face mill. Notice we got some circular inserts on this particular face mill here. So let's go ahead and get this set up in our tool database as well. So I'll go ahead and click New Tool. In this case, this is going to be a face mill. So I'm going to click on face mill. Now, I'm going to, again, this is MSC's catalog. It is a Sandvik Cormat cutting tool. So this would kind of depend on how your company wants to kind of name and define this tooling for everybody to know. Right now, I'm just going to kind of copy and paste the brand here for my description. Might not be enough for me. Sandvik Cormat Inductible. We'll go ahead and put the vendor is MSC Industrial Supply Company. So notice as we take a look, they have their product number and their manufacturer's number here as well. So, and both of these would be pretty good information to have. I don't know that it is critical for both. So I'm kind of tend to lean on if I can get more information. I'm probably better so long as it lets me put that into the product ID, which it does. So I'm going to go ahead and do that because maybe MSC here is not my only supplier for this Sandvik tool holder. Maybe I have a couple of other suppliers there as well. So that manufacturing number becomes just as important to me as the actual MSC number. In this case, I will go ahead and link. So I'll copy and paste that link over here into this. And now we can kind of go ahead and get started setting all the other parameters. All right. It is a face mill. In this case, it is in, I believe this is a metric size. So let's take a look. Yeah, so this is metric size. So the cutting diameter is in 42 millimeters. Now, I'm not going to change this to millimeters, and I'll show you why here in a second. So, because I want to kind of keep some things in inches for myself. So here where it says diameter, I'm going to go ahead and type in 42 millimeter and hit enter. And notice it automatically kind of gives me the actual size. It converts between millimeters and inches for me. So shaft diameter. So here's the diameter. So kind of again notice the difference. So the overall diameter is right here. The shaft diameter is right here. And as I take a look at this, I can also see this is what's referred to as an HSK end mill holder, kind of going in with that there as well. So I don't have all of the other information on this, so we can kind of take a look here and see. This is giving us more information. The maximum depth of cut is 0.1969. Maximum depth of cut in millimeters, so this decimal inches. We given the shank diameter, cutting directions right hand. It's the Quorum Mill 600 is the series. Notice the maximum RPM on this one. It's got 5 cut inserts here as well. So we need to kind of go back in and put some more of this information. Now, if I were actually doing this to set up and make sure that I had everything taken care of so that I could make sure my simulation is 100% correct, I would need to make sure that all of these are good and in good condition as well. on the short side of this, just to make sure that we can generate a good code. To be honest with you, the only thing I really need um, to make sure of in terms of this posting out for just a 3-axis mill is just the outside diameter set. So if I'm live tool and using live tooling where there might be interference issues with that cutting tool, I'm probably going to make sure that I have a lot more of those sizes set here for the machine and for the simulation, so I can double check and make sure it's not going to crash anywhere. So, all right, shaft holder, I think I mentioned this is a HSK, probably the HSK 40. So you can kind of see how that pops in over here. Let's go ahead and put the cutting data. Now, notice the maximum RPM on this one here in a cutting data is 22,200. Again, our machine is not capable of that. So we're going to just kind of put 2,000 in there. So, and in this case, the feed per tooth would be very, very low. So we would probably be looking at catalogs, and I'm going to come back. We'll take a look later, and so kind of pull some of this information from some of the Sandvik catalogs and stuff, and see what their recommendation is in terms of cutting feed per tooth. But I can tell you from experience with that type of an insert, with the circular inserts, we could probably generate about 20,000 IPR feed per tooth on that. Notice how much our feed rate actually increases. So we're up to like 240 inches per minute at 2,000 RPM. So we would probably kind of take a look at that and decide which material are we cutting. Is this a realistic feed rate? Probably not. So we might back this down. So 120 inches a minute might be appropriate in some. I'll tell you, on our machines, we're getting close to our actual maximum feed rates. So 40 inches a minute is pretty high. They're saying 3 thousandths actual feed per tooth. So which is probably a little bit more realistic for what we would be cutting, especially with some free cutting steel. Aluminum, I'm definitely doing 40 inches a minute. Some of the free cutting steel would probably be somewhere around 20 inches per minute. And again, you're going to consult the catalogs and make sure we are putting this in here as the default settings for that tool anytime we call it in. Of course, we could also change this before we post-process the tool out, and we can also manually edit if we need to for stuff like that as well. Disable the coolant. So take a look at the post-processor. We definitely want to make sure that our tool numbers are good. In this case, this is not a live tool either. We're not manually tool changing this, so we'll leave that as is and go ahead and hit OK. Now we have that face mill in here as well. So another tool list to add in and make sure that we're good to go with.